Hello friends, welcome on my channel Jagdish Chaubey. This part 4 of heat treatment series 2 is on gas carburizing. Prior to this I have already told you about solid and liquid carburizing. So this particular part 4 is on gas carburizing. So let us see what it contains. So content. First of all, before going into details, the flashback in heat treatment series 1, I produced 8 videos, part 1 to 5 as iron carbide diagram, TTT curves, CCT curves, microstructures, then basic heat treatment processes such as annealing, normalizing, hardening and tempering. Part 6 to 8, it was on concept of heat treatment, that is hardenability, quenching and effect of alloying elements. In the current series of heat treatment 2, I have produced till now 3 videos. Part 1 introductory, part 2 one was solid or pack carburizing, part 3 on liquid carburizing, and this current video, that is part 4, is on gas carburizing. So covering this carburizing, I have covered solid, liquid, and I will be covering gas carburizing. So let's see the coverage. In coverage, first of all, input steel. In this, the same mild steel or low carbon alloy steels can be used for this particular process. And if you want to know in the detail, then I have also already mentioned here IS 4432. It is specification for case hardening steel, means all those steels which can be case hardened, that can be seen here in this particular IS 4432. So if you want to know in the detail about the various steel, you go to this IS 4432. This is just for your information. Okay. Now the second is gas carburizing process. What is this process is there? And then advantage and disadvantages of this process. And the last is application. So this will be the coverage in this particular part 4 of gas carburizing. Okay. So first of all, process. Gas carburizing is one of the popular case hardening process wherein the part is exposed to carbon-rich gaseous atmosphere to produce a hard surface or case. So it's very simple that in this case we have to expose the part in carbon-rich gaseous atmosphere. Okay, that is why it is called gas carburizing, because you are exposing the part in the gaseous atmosphere. And then you produce a hard surface, and then you produce a hard surface or case when it is exposed to the gaseous atmosphere. How this is done, this I will tell in the next slide. What are the equipments used? Generally this pit type gas carburizing furnaces, and the second one is continuous carburizing furnaces. These are the basic 2 furnaces which are being used for this gas carburizing. Out of this, I think this pit type furnace is more popular. Okay, so I'll not tell much detail about these furnaces because I have to cover the process basically. What are the fixtures used? See, these are the various fixtures which are used for gas carburizing. This is a base spider. It is, you can see it here also. Then on this there is a stand, and then you can keep various trays like this also. See, lower. The holes are there perforated, and this you put the component and that hangs in the furnace. Okay, so these are various types of, this is also a hanging type of fixture. These are trays type where you need to put pieces flat here and then 1 to 1 layer. So these are the tray type, and this is the hanging one type. So these are the some of the fixtures which are being used. There are a number of fixtures. This tempering temperature 150, 200, it all depends upon what surface hardness you want. In case if you want a higher surface hardness, you have to go slightly low. If you want to have a lower surface hardness in the same range, then generally you should go around 180, 190 degrees centigrade for sufficient hours so that you get a particular surface hardness. In such cases, one sample piece is taken just to confirm before unloading a charge that you are getting a proper surface hardness and even microstructure also. So after this is confirmed, then you unload the charge from the furnace. Okay, so the charge is unloaded, In this particular case, the total time which is taken from loading of the furnace to the unloading of the charge is in general 8 to 12 hours. In some cases, in some practices, you can reduce this time. For that, you have to increase the carburizing temperature. Maybe you have to go for, instead of 900, 940, you have to go for 1000 degree centigrade. Sometimes you go to 1000 or 980, around that. But I will not advise you to go on the higher side of the furnace, because if you go on the higher side of the temperature, like 1000 degree centigrade, to achieve a particular case depth in a very quick time, then it will spoil your furnace. The brake linings will be spoiled, then the whatever fixtures and all those things you are using, there also this life is reduced. So it will give you later on a very maintenance issues are there. So try to avoid high temperature carburizing or diffusion. You have to go around 920 to 940 to achieve a particular case depth in most of the case hardening steel. Correct? So the most time taken is, so the loading time to unloading time, the charge will take around 8 to 12 hours. This is how this gas carburizing is being done, and this is all about the process. Okay. Now, what are the major reactions which take place in this particular gas carburizing? First of all, gases which are present in the furnace atmosphere are carbon monoxide, carbon dioxide, nitrogen, hydrogen, water, and CH4, methane is there. These two, CH4 and CO, they are primarily responsible for giving a hard case. Okay. So now you see the various reactions which takes place, like CO plus H2O, it forms CO2 and H2. Then this 2CO, this is a reversible reaction. This TCO is also a reversible reaction. It breaks into carbon, which goes into the surface. Okay, and then plus CO2. Similarly, this CO again, when it reacts with hydrogen, it gives carbon at the surface and then H2O. So this water vapors or moisture content is there here. Okay. Similarly, the third reaction, CH4 methane with CO2, it gives 2CO, again 2H2. Okay. And this 2CO again goes back in this stage, and gives again. So this cycles continues. Again here in CH4, it reacts with water to give CO and 3H2. And lastly, this CH4, it itself breaks into carbon, which goes into the iron or in the surface, and there is a 2H2. Okay. So hydrogen is there. Okay. So these are the various reactions which takes place inside the furnace, and the area which are responsible for carbon penetration, that is I have shown here with red C. This red color C is carbon, which is a nascent carbon which goes inside the furnace. When you give this diffusion cycle, this is the carbon which goes into the, or which penetrates into the carbon parts, and thereby when you quench it, it gives a very good hardness and temper it. Okay, so you get a very hard case in that particular case, depending upon carburizing holding time or diffusion cycle holding time, you get case, okay, of very hard surface. Correct. Generally, the case depth achieved in this gas carburizing is 0.5 to 3 mm. You can go higher, you can go lower also, but that is not advisable. In general, up to 2 millimeter people are generally using for all practical purposes, but 3 millimeter you can go it. Slightly you have to give, this total time will increase because you have to go a higher depth. Okay. So this is all about major reactions which takes place and the case depth which can be achieved in gas carburizing. Okay. So I'll go through this step in gas carburizing. First of all, heating to 700 to 8 degrees centigrade in neutral atmosphere. Then entry of carburizing medium and heating up to carburizing temperature of 920 to 940. Okay. Then holding at carburizing temperature depending on the case depth you want. At predetermined flow rate, this all its gaseous flow are controlled by flow rate. There is a flow meter is there through which you measure it, and then you allow the gases to go, or even this liquid fluid also is controlled by this flow rate. And this carbon potential also you have to maintain accordingly what case depth you want. After carburizing cycle, you have to go for a diffusion cycle at the almost same temperature, maybe 10 degree less, for a predetermined time with reduced feed rate. Here you have to slightly reduce the feed rate as well as CP also, like 0.8 to 0.7, okay, so as to control the entire case, okay. Then cooling from carburizing temperature to quenching temperature, that is generally we keep it around 840. After, we have to hold at quenching temperature for stabilization purpose. Stabilization means where there has to be a uniform structure throughout the part, so it gets stabilized with the same or reduced CP. Now, after maintaining this 30 minutes holding time, you have to quench in well agitated quenching oil tank, correct? Then go for washing by dipping or jet spray, simple water wash, okay? Then tempering between 150 to 200 degrees centigrade for 2 hours, generally in tempering furnaces. And after that, unloading, salt blasting, and dispatch. Okay. This here I will tell you something about quenching. In case of quenching, both the quenching temperature as well as oil temperature or total oil tank conditions, you have to maintain proper agitation. Has to be all around. It's not one-sided. Sometimes fans are down below are situated at only one side. It is not desired. You have to place on the both the sides so the agitation is total. Then heat transfer through recuperators is also required. Through recuperators, you have to provide recuperators so that heat transfer is transferred from quenching tank. The hot oil will go inside and the fresh oil will come outside, and it will maintain the level as well as the temperature of the oil. Okay, these two conditions are very required. And the third is your transfer time. If your transfer time is delayed, then it will be a delayed quench. Sometimes it happens in general in practice that you are shifting the load and in between the crane there is some problem, electrical issue, and it's stuck there, but still you go and you quench it. That is not desirable. You will not get a good surface hardness and good microstructure. So quenching time has to be as quick as possible. Okay. So this care you have to take during this quenching period, that you have to maintain oil temperature proper. The heating quenching temperature in the furnace, that is 840, has to be maintained, and the transfer time has to be very minimum. Okay, and the oil bath has to be well agitated, and the temperature should be also well maintained, oil temperature. So these precautions you have to take when you are quenching it, okay, to get a good surface hardness and a good surface microstructure. Okay. Now, factors which are influencing quality in gas carburizing. Surface condition of the component, that is there. The surface should be properly cleaned. There should not be any rust or dirty or paint, all those things. You have to remove it first. Okay. So surface has to be very clean before you go for this gas carburizing. Then correctness of temperature at different stages. Whatever temperature I have mentioned at various stages, like carburizing, diffusion, tempering, all these temperatures are to be maintained properly. Ensuring established feed rate, CP at various stages. This also is required. Whatever feed rates through flow control valves and carbon potential indicators, that has to be maintained at the desired level. Okay. Then holding and soaking time also has to be taken care. Then transfer time, the most important one. Time for quenching, that is also maintained as low as possible. Quenching condition, oil temperature, agitation, volume of oil, that has also to be maintained. Then proper washing and salt blasting. After that, accuracy of monitoring instrument. Whatever instrument you are using in this particular gas carburizing, whether it is a temperature controller, then this is flow rate. For this, you are using flow valve meters. Then carbon potential also you control it. Then dew point measurements are also there. So all these measurements, all those instruments which are being used for controlling all these parameters are to be properly calibrated, and it has to be accurate so that you get a good result. So accuracy of monitoring instruments are to be maintained properly. And after that, upkeep of the furnace, like there should not be any leakage. For that, you have to go for time to time preventive maintenance, as that you avoid leakages and all those things inside the furnace. So these are factors you can see in the influence gas carburizing, as well as there are also a precautionary measure when you should take it when you are going for a gas carburizing system. Okay. Then what are the advantages and disadvantages? First of all, it has got a very good case control. Case control is very good as compared to other processes. Then uniform case depth can be also achieved. Uniformity also is achieved. Then mass production. This is very popular for mass production as compared to your solid carburizing or liquid carburizing. This is a major gas carburizing process which is used for mass production purpose. So wherever there is a mass production is required, you have to go for this gas carburizing. Then increased wear and corrosion. That is the thing when you get this hard surface, okay, you get a very good wear resistance as well as corrosion resistance. Variety of components can be carburized. This gas carburizing can be done for a various type of components, whether it's small or big, or of a different types of shapes. The only condition is you have to maintain fixture as per the part configuration, so that you can hang the parts in the fixture and it goes in the furnace. Then this particular process can be automated. SCADA system can be introduced, and nowadays the most of the cases this SCADA is used to control all these things, because you have to just give input, various temperature, holding time, cycle time, okay, and then accordingly system will maintain everything, and you have to control through only your cabin. While sitting in cabin you can control everything, and in fact you can see also how things are going inside the furnace. So nowadays the very good system, and this particular gas carburizing can be monitored by using this automated system like SCADA system. Okay, so these are the advantages, and the disadvantages are it reduces the ductility of the part because of the very high carbon content. The ductility is reduced. Increased machining cost, because again the same thing, because of the very high hardness you have to take a different type of tools having a good hardness which can machine it out, otherwise it will be a failure. Then high maintenance cost because of the furnace quenching system and all that thing. You have to go for a high maintenance cost. And possibility of fire hazards during oil quenching. This also I just now explained, because if you are not maintaining the oil temperature proper, and when we are quenching it, when you are quenching it, the oil will catch fire and it will be very hazardous. So in that particular case, to avoid such thing, you have to put a cover. It's a sliding cover. As soon as you are quenching and charge goes inside, you have to cover it so that the flames they don't come out, and there is no oxygen which is coming from top and going into the oil. So it will control the fire, and the fire will extinguish after some time. So this fire hazard is a very big disadvantage. So this has to be taken care when you are going for gas carburizing. So these are various advantages and disadvantages that I have told you. Now I'll go for automation. Now I'll go for application part. Used for automotive parts, small to big sizes. Okay, I have just shown you different parts suitable for bearing and rotating parts also. Ball bearings and rotating parts like this ball bearing, this crown wheel pinion, I have shown it here. So these can be used. Then applicable for aerospace industries and springs also. Highly stretched parts which are very highly stretched, that can also be gas carburized very easily. The last one is it improves wear resistance, corrosion resistance, fatigue resistance, and impact strength of the part. This is a common feature for all carburized parts. Okay, so all these properties they increase when you go for gas carburizing. So friends, I have told you enough in this gas carburizing. In fact, if I repeat it, I first of all introduce you to this gas carburizing with different type of furnaces which are being used. What is the definition of this gas carburizing, and after that, what are the various systems in the sense. And after that, I told you about the process cycle also with different cycle measurements. And after that, I told you about process cycle and about different types of gases which are being used in this gas carburizing furnace, and particularly for methane and CO, which are responsible for giving you a hard case. And I have given all the example, particularly on a liquid based, okay, where this liquid alcohol is used and it is controlled through drip feed rate. So these examples are basically for those type of cases, pit type of furnace where you are using a liquid alcohol as a gas carburizing medium. Okay. Then after that, whatever the various reactions which are taking place inside the furnace and what are the reactions for which this carbon deposition is responsible. Okay. And then in diffusion cycle, how this carbon penetrates from surface to inside, and after quenching you get a very good surface hardness, and then you temper it. So all these things I have told you. Then advantages and disadvantages of the process, and lastly application of the part. So how did you like this presentation? If you have liked this, then kindly like on my YouTube channel, and you can give suggestions also for further improvement, okay, in your comment box. And if you are new to my channel, then please subscribe my channel also, okay. So with these words, I'll complete this particular process here itself. The next part is coming is heat treatment series 2, part 5, and that will be on night riding. So thanks for your patience listening. Thank you very much.